So, dear students, so now that we have seen what are the various population forecasting methods, we'll work out a few problems so that the concept will be more clear. So, we have seen the arithmetical increase method or the arithmetical average method. So, in this method, we assume that the rate of change of population with respect to time is a constant, and according to this method, the total population for any future decade is given by the expression Pn is equal to Po plus n into x bar, where Pn represents the population after n decades, Po represents the present population, n represents the number of decades, and x bar represents the average increase in the population. So, just go through the problem. So, the problem states that the population of 5 decades from 1930 to 1970 is given below. Find out the population after 1, 2 and 3 decades beyond the last known decade. So, here the last known decade is 1970, and this has to be done by using the arithmetic increase method. So, as you see here, the data for the population for various years from 1930 to 1970 is as given in the table. So, we have to compute the population for 1, 2 and 3 decades beyond the last decade. So, here the last decade is 1970. So, we have to compute the population for 1980, 1990 and 2000. So, we'll see how this can be computed. So, firstly, in order to simplify the process, we have to record these data, the available data as represented here. We can enter them in various columns. So, the first column comprises of the year, and the second column the data, that is a population data for each of these years, and in the third column we are going to find out what is the increase in the population. So, the first column and the second column, the data is as given in the problem. The third column we will be finding out the values. So, we know that in the year 1930 the population is 25,000. See, as you see here, in the year 1930 the population is 25,000, and in 1940 the population is 28,000. So, obviously the increase in population for this decade, so one decade means 10 years. So, after 1930, 10 years after 1930, the population has risen to 28,000. That means the increase in population is 3,000. Likewise, if you take the case of 1940 and 1950, the population in 1940 is 28,000 and the population in 1950 is 34,000. That means for that particular decade, the increase in population is 6,000. From 28,000 to 34,000, we see that 6,000 more has increased in one decade. Likewise, we have to compute the increase in population for all the remaining decades. So, after computing them, we have to find out the total. So, for the 4 decades, the total increase in population is 22,000. So, then we can compute what is the average increase per decade, that is x bar. So, average increase per decade x bar is 22,000 divided by 4, that is 5,500. So, thus we got the average increase in the population. So, this data is needed for computing the population of future decades. So, from the expression Pn is equal to Po plus n into x bar. This is the expression for finding out the population of nth decade. So, firstly, as per the problem, we have to find out the population after one decade beyond 1970. So, one decade after 1970 means the population in 1980. So, that is Pn. So, here n means the number of decades from 1970 to 1980 means one decade. So, the value of n is 1, and Po is the present population, that is the population in 1970. So, the population in 1980 is equal to the population in 1970 plus n into x bar. So, here n means the number of decades, that is 1, and of course x bar we have computed earlier, that is 5,500. So by substituting these values, that is the population in 1970 plus 1 into x bar, we can find out what is the population in 1980. So thus the population in 1980 is equal to 52,500. Similarly, the population after 2 decades beyond 1970. So 2 decades beyond 1970 means 1980. So in 1990. So here after 2 decades, so that means n is equal to, in this expression, this is the first expression, so here n is equal to 2. X bar, of course, we have computed, and the population, present population, is the population in 1970. So from this expression, again you can substitute and obtain the value of the population after 2 decades. Likewise, again the population after 3 decades beyond 1970. Again here x bar is the same, only thing n varies. N will be 3 after 3 decades, means in 2000. So population in 2000 is equal to population in 1970, that is the present population which is already known, plus n into x bar. N is 3 and x bar, of course, 5500. Substitute these values and find out the population for the year 2000. So this is how we compute the population by the arithmetic average method. I hope it is clear.